All right, for part B, we have x equals secant t and y equals tangent t. So before we get the rectangular equations, why don't we plot this first by choosing simple t values? And these are trig functions. I would go with t values ranging from, let's say, 0 to 2 pi again. Even though tan is a pi periodic function, but secant is still 2 pi periodic, I think you better keep the t range to be like 0 and 2 pi, the full 2 pi length, to keep it with an interval coming with like length 2 pi. Okay, so let's see what kind of graph we have here. So again, put your calculators in the radian mode and then try to sort of like evaluate x and y at those points. We start with t equals 0. Let's see where we are on the curve. X is equal to 1 and y equals 0. We are right here, okay, right on the x-axis and the positive side of that, okay? And then as you increase t from 0 to pi over 6, you get 1.15 and 0.57. So here we go. I'm going in this direction, okay? And the next one is going to be 2 and 1.73. Here we go. As you see that I'm going in this direction, okay? But let's see what happens. When t equals 2 pi over 3, then all of a sudden I go back to negative x and negative y, which is negative 2 and negative 1.732. Let's just find where that is. Here we go. So how in the heaven I jump from somewhere here to somewhere here, like from first quadrant to third quadrant. So what happened over there? You have to think about it as you watch this video, because I'll explain that in a few seconds, okay? And then we have 5 pi over 6 and pi. Okay, so we got those points covered. In fact, I can keep moving all the way to 4 pi over 3, all the way to 4 pi over 3 to get the point to be like negative 2 and 1.732. So that means I'm still moving in this direction. Okay. All right, that sounds interesting. And all of a sudden, when I hit 5 pi over 3, I go back a positive x value and negative y value. That means I'm in fourth quadrant. So I was here in the second quadrant, and all of a sudden, I jump right here, right at this point in the fourth quadrant. That's interesting. And I keep moving, and obviously at 2 pi, I'm going to go back to where I start. So along the way, I also pass through this point here. Okay, so my direction is still like that. Okay, so some interesting stuff going on. Obviously, if you choose your t interval more appropriately, you don't have those jumps. But the reason why we have jumps is because we have the graph of hyperbola, and hyperbolas come with asymptotes, right? Here we go. Here are my asymptotes. And here is another one. That's the reason of jumping from one branch to another one for different choices of t in the line. Okay, so it's simply because we have asymptotes over there, and if you remember the domain of these functions, tan may blow up for certain t values. That's why tan also has itself vertical asymptotes, and secant has as well vertical asymptotes. So you got to be careful on that. So now the question is like, how am I going to get the rectangular form of that graph, which is in fact a hyperbola, right? So let's just use this identity here, another Pythagorean identity. Okay, so let me just write that down. So secant squared theta minus tan squared theta is equal to 1. Okay, so I'm going to use this identity. So that tells me that x squared minus y squared equals 1. So in fact, in one shot, if you know this identity, in one shot, you can get down to the rectangular form of the equation of hyperbola here. So x minus 0 squared, 1 squared minus y minus 0 squared over 1 squared is equal to 1. Okay, this is the form. This is a hyperbola centered at the origin. Okay, and A and B are just 1. You can go ahead and find C. You can go ahead and find the equations of asymptotes, but the question is not asking for that. So, in the statement of the question, we're just fine to write down the rectangular equation. Here we go. We wrote it. But again, it's your call to dive in this further and check the other properties of hyperbola. Okay. All right. So I'm gonna move on to part C in the next video. Please continue that. I'll see you there. Bye.